Okay, welcome to this lesson on scientific notation. This is something that as a science teacher, I use quite frequently, as a physics teacher more specifically, and you may or may not have seen it. Lots of people see scientific notation numbers and don't really know what it means. But when I say that, I mean if you've ever seen a number that looks like this, 1.5 times 10 to the something, right? That would be what we call scientific notation. And the reason why it gets used, it's basically so that you can write either very big numbers or very small numbers a little simpler. And as you get writing along, you'll see, this is the mass of the Earth. And you might say, well, why do I care? But certainly in physics, we care all the time. When we talk about something about gravity, the mass of the Earth is very relevant. But this is the mass of the Earth, and quite frankly, this is too hard for me to read or interpret. Right? And I don't want to. But, I can, because I'm good at scientific notation, I can easily say, well, I know it off by heart, but this is a much nicer number for me to read. And that's what this mass of the Earth is. 5.98 times 10 to the 24 kilograms. And it's quicker for me to compare that, say, to the mass of the Sun. You don't need to write this, but the mass of the Sun is 1.99 times 10 to the 30. Now, so if I had, if I was going to write down the mass of the Sun, then it would be even a bigger number, more zeros, right? And that's just too hard to read, and quite frankly, not worth my time. So, and your time or anybody else's, or your textbook reader times, because I know if you take any senior physics, you're going to see, or chemistry, you're going to see scientific notation all the time. Okay, so that's what it is, and let me just show you how, how do you go from here to here. And the reason we teach it in math class is that it's, related to exponents. Okay? Scientific notation is special because there's always this times 10 business, right? Well, let me show you. Basically, I'm going to show you kind of what it means, and then I'm going to show you the quick and dirty how to do it. And we're not going to do small numbers, just big numbers, and we'll leave that to hopefully your science teacher, maybe me. We'll teach you that at a later date. Okay. So first of all, let's just deal with a smaller number. So the diameter of the Earth is 12,700 kilometers. Now, often you wouldn't write a number like 12,700 kilometers in scientific notation, but let's do that because it's just smaller for us to work in. The idea is essentially this, that 1,270 No, I said that wrong. 12,700 is the same as 1,270 times 10. Right? Those are the same number. Or I could even just say times 10 to the 1, because 10 to the 1 is the same as 10. So you've got 1270 times 10. Well, you kind of just, scientific notation is just keep following that train of thought. So what if I said, well, it's the same as 127 times 10 to the 1 times 10 to the 1, right? Which really is 127, and we know from the product rule, 10 squared. 1 plus 1 is 2, right? Remember the product rule? Same base, 1 plus 1 is 2. And then I could say, well, that's really 12.7 times 10 squared times another 10, which is really 12.7 times 10 to the 3, right? So that's a 1. So 10 to the 3. It's still a 2, by the way. And then proper scientific notation is usually one number on the left of the decimal place. So I'm going to say 1.27, again, times 10 to the 3 times 10, which is 1.27 times 10 to the 4. And that's the end result. That's this number in scientific notation. Okay? So if you're asked for scientific notation of 12,700 kilometers, you'd say that's 1.27 times 10 to the 4. Now, obviously, you would never do the same this whole thing. That'd be a huge waste of your time. I'm going to show you just the quick rule for what it means. Okay, and that's on the next page. Just the quick, not what it means actually, but just how to do it. Just a quick thing. If we say the term standard form, that would be the regular number. Okay? And that would be 12,700. Scientific notation is with the exponent. And proper form is generally to have one number on the left of the decimal place and the remainder of the non-zero numbers on the right. Okay? So let's just go to the next page and go through, a kind of longer than necessary. I say quick and easy, and it's easy once you've done it a few times. Okay? So the example we're going to follow is, we're just going to do this 6,700. Again, a small number, but then you get the idea. So it says first step, place one number on the left of the decimal and the rest of the non-zero on the right. So that would just be, 6.1 on the left and the rest of the non-zero. So I'm not going to bother with the 0, 0. I'm just writing 1 on each side. Then you add times 10 to, so 6.7 times 10. And the real trick, really, is determining the number to put as your exponent. And what the number is the total number of digits subtract 1. So this has 4 digits, right? That's 4 digits. So my exponent then is going to be 4, take away 1, or 3. Okay? So then you just write out the full number. 6.7 times 10 to the 3. Okay? So that is 6,700 in scientific notation. And then the question of whether it makes sense again is not necessary for you to do every time you do it, but it's that same thing. If I said that would really mean 6.7 times 10 times 10 times 10, right? 10 to the 3, 1, 2, 3, equals 670. Just work our way back up, right? Times 10. Oops, I missed a step. Equals 6.67 times 10 times 10. Right? So I did this multiply, and that gives me 67 with 2 10s left over. Then I do this multiply with 1, and I end up with 6,700. Okay? You don't have to do the backwards, but that's what it is. Okay? Moving down to another example. The mass of the sun is that huge number. What's that in scientific notation? Now, I actually told you the answer already, but let's just go ahead and follow the steps that I told you. One number on the left of the decimal, the rest of the non-zero on the right, and then the total number of digits subtract 1. So now you got to go through this hassle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 31. It's 31. So times 10, not to the 31, because you have to do the number of digits subtract 1, so times 10 to the 30. Okay? And that's how you do it. Another big obstacle with working with scientific notation is getting it in your calculator properly, and we'll do that in class together. Okay? So any questions you still have, go ahead, write it down, but that's the lesson on scientific notation.